Andy DeGeorge asks if I can give XC Basic a look and share my thoughts about it. This is a little different. No, I'm not going to put a camera on my Mac keyboard. No hands this video, sorry. So I'm here at the xc-basic.net website. Welcome to the XC Basic Wiki. XC Basic is a dialect of the basic programming language for the Commodore 64, and XC Basic 64 is a cross-compiler that compiles the source code to 6502 machine code. Some of the advantages of programming it are cross-development, that you can use your favorite OS and editor. Well, my favorite OS is Basic 2.0 on a C64, so I can't use that, but that's okay. Higher execution speed because there's no interpreter. The source is compiled to pure machine code, and that's totally true. More available RAM. The runtime banks out the basic ROM by default, thus allowing to have a continuous RAM space from 0801 to CFFF about 50K. Advanced features. Hope you don't mind me highlighting the text here. Complex expressions are allowed. Global and local variables, integer and floating point types, typecasting, constants, procedures, user-defined functions, recursive procedure calls, inclusion of other source or binary files, C-like strings, inline assembly support, and automatic code optimizer. It stands for Cross-Compiled Basic. Okay, so this is the documentation. It seems pretty good. The release here, the current version is 2.3.02, which I have downloaded. The source code is up on GitHub, if you're into that sort of thing. To use it, it's pretty easy. First, you install DASM, which is a 6502 cross-assembler that's been around for ages. I've been using it on and off occasionally for, it's got to be 20 years. So it's still around. And I just downloaded it. And likewise, I grabbed the XC Basic. Both of them are just a single executable. If you're on Windows, this would probably be just as easy or easier. Or if you're on Linux, DASM and XC Basic are available for both. And then to use it, you just call XC Basic 64 with some options. The source file, you just give it the main source file, but you can include others if you're making a bigger program. And then the target, that's the C64 binary that you'll run in your emulator, or copy onto, an SD card to run on the real thing. A few command line options there. And we'll just look at a bit of the documentation and then run an example or two. The syntax are just plain ASCII files, as you might expect. You don't use line numbers. Instead, you use labels that work very much the same as assembly language labels. It ignores white space. That's nice. So you can do tabs or whatever suits you. And you can even apparently do the horrible stuff that I do in regular CBM Basic of just leave all the spaces out. Just multi-line statements. You can go onto multiple lines as long as you put a tilde at the very end. By default, it's case sensitive, but there's a compiler option to turn that off. Identifiers are much the same as 64 Basic. You can't start with a keyword like rem. You can't start with a number. And you can include files with the directives. So if you want to be tidy and spread your source code across multiple files, you can. It has rem like C64 Basic, but you can also use an apostrophe or a semicolon like most 6502 assemblers do. String literals. These are kind of neat. You can do little escape sequences here, and there's some either with a number of the Petsky code, or if you want to clear, you can type in that. Actually makes it look very much like the old school magazine listings of Ahoy. And you can also do character literals if you do a single quote. Numeric literals. So you have 3 data types here. A byte, which is between 0 and 255. An integer, which is, this looked a little weird at first, but it makes sense. An integer is between negative 32,768 or 65535. It looked like it would be a 16-bit signed integer like C64 BASIC, but going up to here makes it seem like it's, what would that be, 16 and a half bits. But really, there's overlap. You can go from negative 32768 to positive 32767 as a regular 16-bit signed integer, or optionally it can be treated as an unsigned depending on context. So in the context of a poke, it expects an unsigned integer. So it's not that you can actually store 60 and a half bits worth of integer. It's just that depending on context, it can be interpreted either as unsigned or signed. If you include a decimal point, then it'll be a floating point number, and it seems to use the basic ROM routines for floating points. So they're equally as good and as bad as C64 BASIC. Like they're going to be a lot slower, so avoid them whenever you can. Oh, this is an explanation about integers and about floats. That you should always put that decimal point if you want to force a float. In addition to decimal, it can handle hex and binary built in. That's nice. Variables. Now, as far as I can tell, variables are totally made at compile time. So whatever you tell the compiler to do, you're not dynamically creating variables or arrays. And you can also force certain variables as fast variables so they get defined 0 page and operate faster. Just allowed up to 15 bytes of 0 page access, but that's better than nothing. And here's these sigils, so you can force a variable to be a byte or a float instead of just defaulting to an integer. And it explains how if one member of an expression is a float, everything else gets converted to float, and otherwise everything will get converted to integers. And then a bit about casting. Actually, as I read this, even though the syntax is basic-like, really I think it's much more a C-type language as far as how it actually works internally for speed. And about arrays, maximum of 2 dimensions and a 15-bit array length. The arrays aren't initialized, so unless you store something in them, they'll just be whatever happened to be in RAM, undefined. And arrays can be a lot faster if both the variable and the index are both byte types, then it can do much faster array lookup. So that's an optimization that's available. Got your regular multiplication, division, addition, subtraction, and your regular relational operators, and an OR. Bitwise, they've added exclusive OR and also used the C-like symbols, the ampersand, the pipe, or whatever, the caret, for the bitwise operators. You can't use and and or, the conditional and and or, as synonyms for the bitwise operators. C64 BASIC lets you, well, actually forces you to just use and or, and it depends on context whether it's bitwise or not. Okay, and then there's a section about strings. That strings, again, this is like C. The string itself is stored in memory as a sequence of bytes, but the variable just holds a pointer to that string. So it says, like when you define the variable. That hello world will be in memory at compile time, not at runtime, because this is compiled. Print, and then when you print it, you're actually just passing a pointer to this string. So you can't do B string equals A string. Well, you can. It's not going to create a new string. It's just going to create a new string pointer that points back to the A string. So again, it's just like pointers in C or even Pascal or whatever. Okay, there is a string copy command, but you have to dimension your own buffer to copy it into there. Okay, so the strings aren't nearly as powerful, but I'm sure they're way faster than C64 BASIC. Procedures, they have their own label, like their own variables and label scope. So that's what a procedure looks like. X, Y, and A are local variables. And you can pass parameters. Okay, and functions, you can call machine language functions and user-defined functions. What do those look like? The fun and end fun. those are great names. The fun is over. The good times are over. Defining functions. Okay, you have to define them before you call them. Well, that makes sense. Oh, okay. And procedures support recursion, but functions don't. Okay, functions have a return value, while procedures, just making sure I understand the difference here. Well, procedures don't return a value, but apparently they can be called recursively. Well, I'm not an expert on this language. I've just been checking it out tonight because Andy asked me to. Okay, and then there's the full command reference. Okay, so they've got some examples here. Let's get into that. Fibonacci series. So I'm just going to copy that code, paste it into this text editor I already got set up. I hope this is visible enough. This is experimental for me. Okay, and then here I am in the XC BASIC, just in my terminal. Those are the files I downloaded. DASM, XC BASIC. I've just got them all in the same folder together. I didn't feel like setting them up any more than that. Here's the build command. Okay, so just XC BASIC. And then I found I had to tell it where DASM was with the .. I guess because I have it in my old folder anyway. I didn't feel like figuring that out. But that made it work. Here's the source file, example.basic. And here's the binary that I want to create. So I'm just going to press return, complete. Okay, and there it's built it, and it tells you where the basic loader is. That's like the stub that we've looked at, the library. So that is the runtime library that's built in. So that's just like not even 1K of library. And then there's the code, which is less than 256 bytes, a bit of data, and the variable space, which is uninitialized. So the total size of this little source code was 170 bytes. It compiles to 985 bytes. And a lot of that is just the fixed library, so it's not like it would always multiply that much. Not that there's this complete correlation between code size and binary size, but no, anyway. Okay, and just here we can just go to the example. I'm just going to run in my old X64 emulator here. There it is, the Fibonacci series. So you see when I list it, It's just a basic header because it's compiled, and it's just calling the machine language that starts up at 2782. So we'll run that again, hold down Control, Fibonacci series. There we go. Okay. So just to look at that code, it's just defining a few variables, and because of that integer limit, I assume that's why the series only goes that far. And it's got a print command. So this is just very simple, basic-like instructions. Okay, this one's more interesting to me. Bouncing ball. We'll copy this code and replace the existing source file. Save it. And we'll again build it here. Okay, and there's our new example. And again, we'll open it with X64. There we go, a bouncing ball. Which is, I think there's some, the C64 user's guide has some of that in Commodore Basic, so this is equivalent. So that's running at a good speed, and we should look at the source code here. So it's using constants, which are, variables that won't change. So therefore they're not variable, they're constant. So the documentation encourages you to use constants whenever you can. Here's our variables, x, y, and a delta x and delta y. I've gotten into this kind of logic. If you don't know about this, check out my VIC-20 episode where I drew out that the Super Expander one for the VIC-20. I'll put a link below. Go sub CLS, and here is CLS, and it just looks like it's a loop poking through memory, and it's actually using a go-to and then a return. And then here's our main loop, character at x, y, ball. Okay, so I guess this is like a poke to screen memory. I'm going to quit that. Let's look at that character at. It outputs a character at a given x and y. Note that the runtime library will not check if the values are within the screen boundaries. It's a convenience wrapper around poke. There you go. Okay, so this is essentially just a poke that does some of the math for you. Okay, and it's also calling this wait frame routine, which is checking the raster line. If it's less than 250, then wait. So this is just like you've seen me do code where I'm checking DO12, which is the current raster line, to slow down the action. So actually, I bet we could remark that out and save it. And build and run. So that looks a lot faster. Can I slow down my emulator? I don't even know. Maximum speed 10%. Okay, so now the emulator is running at 10%, but it still looks like the ball's jumping all around. That is because the screen, the ball is moving many, many times per frame, but the emulator only displays the changes 60 times or 50 times a second. Even though it's slowed down the speed, we're not going to see all the frames, well, they're not frames, all the ball movements in between, because it's moving a whole bunch of steps before the VIC actually draws it and the emulator shows it. Actually, even on the real thing, you wouldn't see the in-between frames. It's like that other time I showed how fast, what it looks like when a sprite is moving across the screen at full tilt with no regard for V-blank, and it's just kind of like a smear. Yeah, so What are my thoughts about this? This seems like a perfectly fine language to play around with. If it's appealing to you, give it a try. Even though in some ways it's way better than C64 BASIC, in some ways it's also less advanced. It's lower level, so it's faster. You'll get better performance out of it, but you'll also have some more limitations that, believe it or not, C64 BASIC doesn't have, such as the strains. 64 BASIC has more powerful strains. It has more powerful error checking. There's a much better chance of C64 BASIC telling you what's wrong at runtime. So if you're totally a beginner programmer, I'm not just talking to you, Andy, but for anybody, if you're a beginner programmer, there's nothing wrong with using C64 BASIC and get a feel of that. But that is not the end-all and be-all of programming, of course. Try as many languages as you can. Whatever is interesting to you, you'll grow as a programmer. So give this a try. And if you're coming from C64 BASIC and you don't think you can handle assembly language, this is actually a good stepping stone in a way. Sorry, I'm not having anything interesting to show you here, am I? Command reference. So what I'm saying is that this will, using something like XC BASIC, will actually move you more into thinking like C-like, which is a step towards assembly language as well. Understanding pointers, understanding those restrictions, not having boundary checking on things. Anyway, this seems fine and fun, and it seems there's some other more advanced game demos I'm not going to get into today, but totally seems worth playing around with. It's not very hard to set up, so I recommend it as a thing to try, and if you like it, is absolutely cool. Go for it. Okay, thanks for your question, Andy.